Okay, bismillah. Starting the live event. Okay, we are going live. Tipah Muhammad Noor is live. Okay. Dan, dah.
Afif boleh mute kau
Unmute. Oh, sorry.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, and a very good morning to all of you. Okay, we have now about 398 attendees. Okay, so thank you for joining our live session today for the naming organic chemistry, systematic and easy, a step-by-step guide. So for today, we are going to teach you, okay, we are going to learn how to give name to IUPAC, to organic compounds using IUPAC nomenclature, okay, IUPAC, okay, IUPAC nomenclature. You can refer to your course book, okay, in page, okay, starting page 135, okay, page 135. So what is IUPAC? Okay, it is the International Union of Pure and Applied Chemistry. Okay, so we use the rules from this IUPAC IUPAC system, okay, to give name to the organic compounds. Okay, so without further ado, okay, we will start our live session now, okay, which will be delivered by Sir Afif Arifin, okay, one of our chemistry instructor in Pusat Tamhidi. Okay, Sir Afif, pass to you.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam. Walhamdulillahirabbil alamin. Amin rabbal alamin. Okay, how are you guys? Okay, hopefully you guys in the pink of health. Okay, make sure you have taken your breakfast. Okay, to be energized to follow my live session about introduction to organic chemistry. And do remember, okay, we will not repeat this content in the lecture. Okay, so follow this live. Okay, and make sure prepare also your books, okay, to fill all the details that I'm going to teach you. Okay, and then we will start now. Okay, the first one, can you see? Okay, the slide. Okay, introduction to organic chemistry. Okay, which is the lesson here is lesson 59, IUPAC nomenclature. Okay, of organic compound. So next. Okay, let's see a bit introduction of IUPAC nomenclature. Okay, the purpose of the IUPAC system of nomenclature is to establish an international standard. Okay, to give a standard name. Okay, compounds to facilitate communication. Okay, to make communication too easy lah. Okay, it is also to give each structure a unique and ambiguous name, okay, and to correlate each name with a unique and an ambiguous, okay, structure. Okay, that is, okay, the IUPAC stands for International Union of Pure and Applied Chemistry. Okay, so do take note these two terms, okay, two terms, prefix and suffix. Okay, fundamental principle IUPAC nomenclature is based on naming a molecule's longest chain carbon. Longest chain. So you can see here, okay, longest chain. Okay, can you see this one? Okay, longest chain carbon. Okay. Connected by a single bond, whether in a continuous chain or in a ring. So prefix. Okay, what is prefix? Prefix is when, okay, the functional group become substituent. Okay, functional group become substituent. And suffix is when the functional group become parent. Parent or root name. Okay, root. Okay, root name of the structure. Okay, so these two terms, okay, we're going to use it, okay, in this naming, in this session. Okay, so next is alkanes and cycloalkanes. Okay, alkanes, what is alkanes? Is the most basic organic lah. Okay, alkanes are the family of saturated, okay, saturated hydrocarbons. Okay, that is molecules containing carbon and hydrogen only, connected by single bonds. Okay, usually saturated, okay, we are referring to this containing carbon and hydrogen and also contain single bonds only. Okay, these molecules can be in continuous chain called linear or acyclic, okay, acyclic, or in rings, okay, in rings called cyclic, okay, cyclic or alicyclic. Please do not be confused with these two terms, okay. Acyclic is another term for linear, alicyclic is another term for cyclic. Okay, so name of alkanes and cycloalkanes are the root, okay, are the root names of the organic compound. Okay, like what? Ethane, methane, propane. Okay, the root name of the organic compound. And then, okay, beginning with the 5-carbon alkane. Okay, 5-carbon alkane. The number of carbon in the chain is indicated by the Greek, okay, or Latin prefix. Rings are designated by the prefix cyclo. Okay, in the geometrical symbols for rings, each apex, okay, apex represents a carbon with the number of hydrogen required to fill its valence. Okay, so this is the first 10. Okay, the first 10 unbranched, okay, alkane. Okay, so this one actually you already learned in high school, the basic one, which is when you have 1 carbon. What is the alkane? What is the name of this organic compound? Let's say here we have CH4. So when you have 1 C, it is methane. Okay, and then when you have 2 C here, it is, okay, ethane. When you have 3 carbon, okay, 3 carbon, 1, 2, 3, it is propane. 4 carbon, okay, 4 carbon butane. So you can see here, the structure, we condense it. Okay, we make it like this. CH3 in bracket, okay, in bracket, okay, CH2, close bracket, and then we put 2. Means that in this chain here, we have actually 2 CH2 and then bond next to the CH3. So total of carbon is 4. Okay, and then 5 is pentane, and 6 is hexane, 7 is heptane, okay, 8 is octane, 9 is nonane, and 10 is decane. Okay, okay, I would like to do some settings here. Okay, okay.
I would really like to talk to you, but as you can hear, the noise is very loud on my side. So while waiting for Mr. Afif to set up his, I think he's trying to set up his whiteboard so that he can draw while teaching. This workshop is usually held in Dewan Kuliah Pusat of USIM. If you have been there before, Dewan Kuliah Pusat can accommodate around 500 people. Are you ready, Afif?
A bit, yeah.
Okay.
Right.
The thing that you need to have the knowledge at the moment here is how to draw the structures using 3 types of form: expanded, condensed, and also skeletal. We usually use condensed because condensed is the easiest to type using Word. We don't have to download the software. So when you are doing your presentation for assignment later, you need to make your slides. It would take a lot of time for you to download CamDraw software and learn how to draw. So the easiest way is for you to Google the image, or you can draw using PowerPoint, or you can
Okay, thank you, Madam Ruby. Okay, I'm sorry for this interruption. Okay, so as you can see in the screen right now, okay, in your screen right now, so we stop here. Okay, the first 10 unbranched alkanes. Okay, so next is what? Okay, some cycloalkanes that we will learn. Okay, we will learn today. Okay, so the first one, this is what we call cyclopropane. Why cyclopropane? You can see here how many C we have. 1, 2, 3. There are 3 C here. So we make it as cyclic structure or alicyclic structure. Okay. Without okay. So this one, kita sambungkan, continue. Okay. Sambungkan bond ni. So we make it as cycle. So this is what we call like a condensed structure. Skeletal. A skeletal structure. Right. This is like expanded. Okay. Expanded structure. Okay. And then next is what? Okay. Can you name this one? As you can see, count first how many C. Okay. So you have here 1, 2, 3, 4. So if for butane, butane, okay, butane, but right now it is in cyclic structure or alicyclic, so it become cyclobutane. And for the next structure, how many C? 1, 2, 3, 4, 5. So 5 carbon here, so it becomes cyclopentane. Okay, cyclopentane. Okay, so that is for some of cycloalkanes in organic compound. Like this is the basic one. Okay. So, and then next, okay, continue with 6 carbon. It become cyclohexane. So usually we will draw the cyclic structure as it is like this. Means that we have to make sure if you further your study in chemistry, in the industrial chemistry, you can you tak boleh nak lukis tu sesuka hati cyclic structure tu. Means that contoh C6 ni, okay, this cyclohexane you nak lukis macam ni. 1, 2, 3, 4, 5, 6. For example, like this, 1, 2, 3, 4, 5, 6, like this. You actually have to draw the cyclic structure, okay, according to this shape, hexagon. Okay, hexagon. So this is wrong lah actually. Okay, so after hexane is what? Heptagon. Okay, heptagon with C, 7C. So this one is 6C. Okay, and then you have cyclooctane. With how many C here? Of course, 8 carbon. Okay, 8 carbon. Okay, so that is for some cycloalkanes. Okay, nomenclature of molecules containing substituent and functional group. Okay, so we have, if you look in your books, starting from page 137. Okay, you can refer to your books, page 137. So you can see in your books, you have lots of table actually. Okay, table 4.11, group A. Okay, right now we categorize this table into group A, group B, group C. Okay, this group have its function. Okay, have its priority. Priority means that yang mana kita kena dahulukan dia sebagai parent ataupun substituent macam tu. Okay, so listed here from highest to lowest priority, except that the substituent within group C. Kalau group C, you can refer to page 138. Okay, ada group C dekat situ. Okay, have equivalent priority. Okay, so the first one, we are going to refer to group A. Okay, group A in your page 137. Okay, functional groups indicated by prefix or suffix. Okay, remember suffix, root or parent. Okay, prefix is what? Prefix substituent. When it become substituent. So in group A, you can see that. Okay, in this table, doesn't show you the arrow, which one is the highest priority, but you can see in your books, at the left side of the table, you can see the arrow going up there, going up to the carboxylic acid. Means that right now, carboxylic acid is the highest priority. Okay, pemasuknya dalam group A ni mean that if in this compound have COOH, okay, means that we have to prioritize carboxylic acid as its parent, as its root name, mean that it will be oic acid. Okay, so you can see here, okay, the structure of COH, okay, actually you have learned carboxylic acid, okay, during SPM, which is COOH. So when carboxylic acid, okay, become substituent, but actually jarang lah kita tengok carboxylic acid ni jadi substituent because it is the highest priority. Okay, ada certain case lah. Okay, so it become carboxy. While suffix, okay, meaning that dia akan jadi parent. Okay, I will put here root or parent. So this one becomes substituent. Okay, substituent. You may put in your table, easier for you to refer. Okay, so it become oic acid. If 1C, if 2C, 1C, methanoic acid. 2C, ethanoic acid. Okay. Second, okay. The second highest priority is what? Okay, these two, I believe that you haven't heard aldehyde and ketone because there's no compound. These two compound doesn't include in your SPM syllabus, right? So aldehyde, what is the functional group of aldehyde? You can see here, you have C double bond O attached with hydrogen H. Okay, basically it is like the same as ketone, but different to ketone is that ketone doesn't have H here. Okay, dia akan ada alkyl group dekat sini. Alkyl group tu apa kelas? Itu adalah like methyl, ethyl, CH3, CH2, CH3. That is what we call alkyl. Okay, back to aldehyde. You can see aldehyde, when it become prefix or substituent, we name it as oxo or formyl. But usually we use oxo. Okay, oxo. And then for suffix or parent, okay, it become al at the end of the name. Okay, the root name. So for example, let's say in that compound, we have the highest priority right now is aldehyde. So it become what? Let's say 2 carbon. It become ethane, ethanal. Ethanal. Okay. And then next, the third one is ketone. So ketone, actually alkyl group, we will put R here. Okay. Okay, so you can see here, if ketone, it only consists C double bond O here, with no H or any other compound. Okay, so the substituent for ketone will be the same as aldehyde, which is oxo. But the root or parent suffix different, which is on. O-N-E is supposed to be 1, but when we pronounce it in the compound, it will become like on. For example, 3C, 3 carbon, propar. So when the ketone is the highest priority in that compound, it will become propanon. Okay, for example, propanon. Okay, propanon. Okay, that is for ketone. The next is alcohol. Of course, you are familiar with alcohol, which is the functional group is OH. Okay, OH. So OH, alcohol, okay, the substituent or prefix for alcohol, we call it as hydroxy. Okay, hydroxy when it becomes substituent. But when it becomes parent or suffix, okay, we put all. Example, ethanol. Ethanol, ethane, ethanol. Okay. Next is amine. Okay, amine. Okay, when we say amine, it will consist this and nitrogen. Okay, that is amine. Okay, amine, you can see here. Okay, the substituent or prefix we call as amino. Okay, amino. Okay, amino. And then the root of parent become amine. Example, ethane, ethanamine. Okay, ethanamine. Okay, and then, okay, finish for group A. So we only have how many compounds? 1, 2, 3, 4, 5. Okay, 5 compounds that is need to be look out lah. Okay, in your compound. Okay, whether which one have higher priority. So that one will be the root name, and other than that, it becomes substituent. Okay, that is for group A. Okay, so next is group B, I believe. Okay, group B, functional groups indicated by suffix only. Okay, by suffix only. Okay, so suffix ni means that it become parent only. Okay, so dia takkan jadi substituent. For example, alkene. Okay, alkene of course lah, structure dia. Okay, as we know, C double bond C for alkene. Okay, C double bond, this is the functional group of alkene. Okay, so it will change the root name to become ene. Example, ethene. Right, ethene, C double bond C. propene, butene, pentene. Okay, and then next is alkyne. Okay, alkyne consists of 3 double bond. Okay, 3 double bond. So when we become suffix, what is the root name? Okay, ethyne, propyne. Right? Okay, that is for group B. So for group C, you can see group C. So for this one, substituent indicated by prefix only. Okay, by prefix only. So you can see here, alkyl. This one that I mentioned before, alkyl. We put SR. Actually, we refer to, let's say it can be CH3, CH3, CH2. Okay, we put SR. Okay, which consists of carbon and hydrogen only. Okay, we put S alkyl. Let's say if 1C here, what is the prefix will be? M. 1C M. M meth. Meth, right? So it become methyl. 2C here become what? Ethyl. 3C, 3 carbon, propyl. Okay. Alkoxy. Okay, alkoxy. Alkyl with oxygen. Okay, alkyl with oxygen. So it become alkoxy. For example, here RO. CH3O. So alkoxy, 1 carbon here, meth, meth. Okay, methoxy. Okay, methoxy. Okay, so if 2C, CH3, CH2O, so it become ethoxy. Okay, ethoxy. Halogen. Okay, halogen. Fluorine become fluoro. Please be careful with the spelling of fluoro. F-L-U-O-R-O. It is not F-L-O-R-O. It is wrong. This is the common mistake for student. Fluoro. F-L-U-O-R-O. Okay. Cl is chloro when we become substituent. Br, bromo. I, iodine, iodo. Okay, iodo. Basically, we add ro at the end of this compound. Fluoro, iodo, chloro, bromo. Okay. So this is for prefix substituent. Okay. So group A, group B, group C. And then next is group D. Okay, group D. Okay. So group C. Group C again. Okay, I'm sorry. Title here supposedly to be group D. Okay, group D. Okay, group D. Group D. Okay, you can see here structure. Okay, NO2. It will become nitro. Okay. Don't be confused with amino. No, amino is only N. Usually NH2. Okay. NCH32, NCH3 or NCH2CH3. But this one is NO2. So it is nitro. C triple bond with N, we call as cyano. Okay, cyano. Okay, cyano. So when it become substituent, okay, it becomes cyano. Okay, this one you can see here, CH double bond CH2. Okay, this is alkene, right? But right now, this alkene, when it becomes substituent, okay, when it becomes substituent, okay, in this let's say in that chain, dalam satu chain tu, in one chain tu ada highest priority than alkene, for example carbohydrate acid, and tiba-tiba ada yang ini sebagai dia punya substituent. So means that this one we call as vinyl. Vinyl. Okay. So and then next this one allyl. Okay. 1, 2, 3. Okay. Allyl. And then this one benzene ring. Okay. Aromatic compound benzene ring. So benzene ring, when it is become substituent, we call it as phenyl. Okay, students do get confused with these two example. Oh, I'm sorry. The slide doesn't show you the benzyl. Okay, never mind. I will draw to you. Okay, benzyl. Okay, benzyl, the difference is that, okay, still it have benzene ring here. But you can see here, after the benzene ring, we have CH2. Only that they attach to the parent or linear structure here. Okay, so this, look carefully, the one that I circle here is what we call as benzyl. Okay, benzyl. Okay, look carefully. The difference between benzyl and phenyl is that benzyl have CH2 after the benzene ring, but phenyl doesn't have any carbon after the benzene. So it become phenyl. Okay, do take note. Put the notes in your books. Okay, what I've mentioned here. Okay, so that is for group D. Okay, group A, group B, group C, and group D. Okay, for groups, you have to memorize. Okay, the priority, which one have the highest priority, which one become the name of the prefix. Okay, so some next table on the page of 139. Okay, class. In this table, you can see that we have some common alkyl groups as substituent. Means that all these compound, okay, when become substituent, what will be the name, what will be the structure and skeletal structure. Okay, as you can see here, the column of skeletal structure is empty, right? So that is your assignment to do it, and inshallah maybe after this next week, Madam Tipah, okay, Madam Tipah will update the answer, okay, in this in the channel or in the by the leaders lah, okay, through the leaders. Okay, so that is your assignment, but I will discuss maybe a certain compound I will choose to discuss. For example, I will choose, okay, isopropyl. Okay, isopropyl. Okay, you can see here in this table we have methane. When methane, 1 carbon. Okay, methyl become methyl. So substituent is CH3. Ethane, 2 carbon. So ethyl. So CH2, CH3. Okay, propane, propyl, 3 carbon. Okay, so ini still become propyl. Okay, but this one, isopropyl class. Okay, isopropyl still consists 3 carbon. So that's why it is still under propane, 3 carbon. Okay, but that, just that isopropyl, the arrangement is different to propyl, which that, okay, you can see propyl here, it is linear. With what I mean by linear means that there's no substituent, just a linear structure. But for isopropyl, we will make it like this. You can see here, okay, this is like, this one is the parent, okay, means that right now is the substituent. So when the substituent is arranged like this, okay, you can see how many C here? 3. 1, 2, 3. So the second carbon of the substituent out of 3 carbon here attached to the parent. So that is what we call isopropyl. Differ to propyl. Let's say ini first carbon, second, third. The linear structure here directly attached to the parent. Okay, we call it as propyl. Okay, propyl. So I will show to you the skeletal for isopropyl only because we will use it to discuss in practice after this. Okay, so let's say this one is the parent. Okay, parent, as you can see in the slide. Okay, so isopropyl. Okay, isopropyl, you can see here, become like this. They say this one, I label as C1 here, compared to this structure. Okay, compared to both of this structure. Okay, C1, C2, C3. See? So this is what we call isopropyl. Okay, this is example for skeletal of isopropyl. So you may try to do for other substituent. Okay, that is your assignment lah. Okay, like assignment. So isopropyl 3C. So butyl, butane, butyl. So 4C. So that will be the arrangement, the linear. Isobutyl. See, under butyl there are so many other substituent, like dia punya anak-anak. Okay, butyl, isobutyl. So how does the arrangement of isobutyl? You can see here. Okay, they are branch, but branch is attached at the second carbon. For example, this one. 1, 2, 3. For example, 3. So there is a substituent in this substituent, right? But all this we call it as isobutyl. Okay, isobutyl. Sec butyl. Okay, sec butyl. Okay, so sec butyl, it attached at the second carbon of the butyl. So 1, 2, 3, 4. Okay, third butyl become like this. Okay, third butyl. So you can see here 1, 2, 3. Okay, different to the. Okay, different. It is different to the isobutyl. Don't get confused. Okay, so you can see here the parent attached directly to the second carbon, and then this second carbon of butyl. You can see here you have 3 more C around that carbon. Right? You have 3 more C around that carbon. Okay, so that is what we call third butyl. Okay, and then pentyl, pent 5 carbon. Oh, neopentyl first. Okay, neopentyl, pentyl 5 carbon, isopentyl. Okay, when we say iso, usually the shape of iso is like this lah. Okay, this one iso. And you have another 2C here. So become isopentyl. And then neopentyl. Okay, shape just nak sama dengan tadi third butyl, just that have extra CH2 here. So it become neopentyl. Okay, neopentyl. Okay, structure. Next is cyclic structure. Cyclopropyl. Okay, cyclobutyl. So like this. Means that what is the difference with cyclopropyl and cyclopropane? Cyclopropane, when it is become a parent, but cyclopropyl, when this cyclopropyl is become the substituent, so we call it as cyclopropyl. Okay, cyclobutyl, okay, from cyclobutane, cyclopentyl from cyclopentane, and then this one benzyl, the one that I've explained before, benzene with CH2. Okay, benzene with CH2. Okay, benzene with CH2. Okay, so differentiate, okay, between phenyl and benzene. See how many times do we remind you about this, because this is the most common mistakes that student do lah. Okay, yang selalu sangat student buat mistake and do get confused between phenyl and benzene. Please take note. Okay, please take note. Okay, benzene, phenyl. Okay, so next. Okay, for this one. Okay, for page 140 about the steps. Okay, I will explain, okay, through the example. Means that we will do the example and then sambil tu saya akan explain step. And then you try to refer to this page 140 lah. Okay. Okay, sambil tu saya akan refer. Okay, step ni. Okay, sebab if I want to read it, akan ambil masa lah. Okay. So, never mind. Okay, we go to the first example. That is practice 4.9 class. Okay, so right now you can start, try to jot down, okay, the name and do take note, okay, what I've mentioned about the steps. Okay, the first step is we have to look in this compound. Is there any highest priority in group A first? In group A. Because of what? In group A will change its root name. Okay, look for this compound. Tengok dulu. Okay, is there any compound from group A? So if you can see here, we doesn't have any carboxylic acid. We doesn't have any alcohol, aldehyde, ketone, amine. So we proceed to next step. Okay, next step is we find the longest chain that we can find. Okay, so the first one is, okay, I will show to you. I will try to use another pencil color. The first one, let's say, if you look this one, we start from, okay, let's say left. 1, 2, 3, 4, 5, 6, 7. Okay. The first linear that we find is consists 7 carbon. Okay. Wait. Try to look for another linear chain of carbon. Okay. For example, can we do this one? Let's say this one. 1, 2, 3, 4, 5. But we go up here because this is still the chain of carbon. 5, 6, 7, 8. So we can see here 7 and 8. Of course, 8 is the longest, right? Okay, so means that the red mark here cannot be used. Tak boleh pakai. So kita clear. Okay, I will clear it. Because I don't want you to get confused. Okay. And then next. The next step is once we already get the longest chain of carbon, try to circle. Okay, try to circle the substituent. Means that mana-mana substituent and mana-mana compound that doesn't include in the longest chain, it will become the substituent. So the first one we have this one, Br, is the first substituent. CH3, second substituent. Cl, CH3, and also this one, CH2, CH3. Okay, next, after that, okay, the chain. Okay, it can also start from here actually. Once we get, okay, it can also start from here class. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the one with the blue start from left, the one with the green start from right. Okay, next step is that, okay, number, if you look at the step number 2 in page 140 class, number the chain in the direction such that the position number of the first substituent is the smaller number. Means that we have to arrange the substituent. The number of substituent right now, we want to make it smaller. Nombor substituent yang kita nak letak dalam naming tu, kita nak yang kecil. For example, okay, we have 5 substituent here, right? Okay, kita ada 5 substituent. So, parent first, okay? I will draft this one. Okay, kita listkan satu-satu. Parent. Since 8, what? 8 is what? Octa. So, alkane. So, octane. So, CH3, kita dah decide dia jadi, it becomes substituent. Okay, kita list dulu. Ini, this one, methyl. Br, bromo. CH3, methyl. Cl is chloro. CH2, CH3 is ethyl. Okay, so the first step is, okay, let's say saya nak buat yang daripada warna biru ni, blue color. Okay, so from the blue color here, we can see here Cl attached at the second carbon, second, Br third, okay, methyl fourth, ethyl at the fifth carbon. Okay, so kita susun ikut alfabet pula. Okay, so 2 chloro C. Sorry.
3 bromo.
3 bromo. Okay. Okay, how to write the name? Okay, we will put 3 bromo. 3 bromo. Why 3? Because we will arrange it, okay, according to the alphabetical order. Okay, 3 bromo because B first. A, B, C, D, E, F, G, B, right? 3 bromo. And then we put dash here, right? 2 chloro, 2 chloro, and then next is methyl and ethyl. Methyl we have 2 here. So when we have 2 methyl, okay, it will become, okay, dimethyl. Okay, you can see in step 4, okay, sorry, step 5, okay, step 5, the second one, in alphabetizing, ignore prefixes like sec, third, di, tri, etc. Okay, means that this di doesn't include, okay, doesn't included in the alphabetical order. Kita tak ambil kira. Supposedly it become 4 dimethyl and then baru ethyl. Tetapi sekarang ni di tu tak dikira. So means that it become 5 ethyl. 5 ethyl. Okay, 5 ethyl. 4 dimethyl octane. Okay. Next, kalau saya ambil yang warna hijau pula. Okay, yang warna hijau. 1, 2, 3, 4. 5, 6, 7. So maksudnya B, bromo. B first kita tulis. Dia akan jadi 6 bromo. 6 bromo, 7 chloro, okay, 4 ethyl, and then 5 dimethyl octane. Okay, so we will compare these two answers, okay, by referring to the step. Okay, if you look at the step 2, okay, the third one. Sorry. I believe that okay, the first one in the step 2, the first point in step 2. Number the chain in the direction such that the position number of first substituent is the smaller number. Means that ni, this one plus kita nak substituent number ni, the one that I underline here, kalau boleh kita nak yang kecil. For example, if I add this up, 3 plus 2 plus 5, 10, 10 plus 8 is 18. Compared to this one, 6 plus 7, okay, 13, 13 plus 4, 17, 17 plus 10 is 27. So it is wrong. Besar sangat. Okay, so this is the correct name. Okay, don't worry, we will do another example. Okay, so this is the first example in practice 4.9. Okay, do remember, look for the group A, which one have the highest priority. Okay, and then next is the longest chain of carbon. And then the third one is, okay, after that, circle, identify the substituent. And then next is, okay, look for the smaller number of substituent. Okay, list of numbering substituent ni mesti smaller. And then the fifth is, okay, make sure you arrange according to the alphabetical order. When you want to write the name, make sure you arrange it according to the alphabetical order. B, C, D, E, F, G, H, I, J, K, and so on. Okay, that is for the first one. First example. Okay, next example. Okay, this one. Okay, so for this one, okay, let's take a look which one have the highest, the longest chain. So if you look at this example, second example, it doesn't have any compound that is from group A. So tak ada yang highest priority. So it become alkane. Okay, so next, okay, saya akan buat dua color juga. Okay, so let's say yang saya nampak panjang is, okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, saya nampak is that here. 1, 2, 3, okay, 4, 5, 6, 7. This is the longest. Compare kalau you ambil yang ini. This one. Kalau you ambil yang bawah ni, this is just, I believe that 6 carbon. Contain only 6 carbon. Right? Okay. So sama, okay, once we identify the longest chain, identify the substituent. So this one becomes substituent. This one substituent. This one substituent. Okay. Substituent, methyl, CH3, methyl. F, fluoro. For this one, how many C? 3. So if 3C, propyl. But is it propyl, the linear propyl, or the one with the branch? So refer back to your table 4.15. Try to compare this substituent. And then you will get it is actually an isopropyl. isopropyl. Okay, isopropyl. So, okay, we already identified the substituent. Okay, and then, okay, take a look. Okay, let's say one start from up there. If you start down here, macam mana? 1, 2, 3, 4, 5, 6, 7. Okay, so the one with the blue color first. So 1, 2, 3, 4, isopropyl. So isopropyl, does it include in the alphabetical order? Yes, it is included. Because, okay, you can take a look at step 5. Okay, step 5, the point number 2. Ignore prefixes like sec, third, di, tri. But include iso and cyclo. Do remember these two only. C, cyclo and I, iso termasuk dalam alphabetical order. Yang lain tak.
Step 5.
Step 5.
1.2.
Point 2, yes.
Okay.
Thank you, Madam Ruby. Okay. So, next is, okay, 4 isopropyl, 5 fluoro, 6 methyl. So, F first, and then I, and then M, right? Alphabetical order. So, it become 5 fluoro, 5 fluoro, okay, 5 fluoro, 6 methyl, okay, 4 isopropyl, okay, 7 is heptane. Heptane. Okay, compared to the green pen. Okay, the green pen, okay, 3 fluoro, 6 methyl, 2 methyl, 4 isopropyl, heptane. Okay, so which one is correct? Try to count the number of substituent, total up. The green one, 3, 2, 5, 5, 4, 9. The blue, okay, so this one is 9. The blue, 5, 6, 11, 11, 4, 15. So this one is wrong. This one is correct. Okay, so hopefully you get it. Okay, try to get to use to this step to name the compound. Okay, and then next. Okay. Okay, so for this one. Okay, so you can see here in third example class. Okay, third example. We have two like dua alkane dekat sini. Two alkanes, two type of alkane. The one with the linear and the one with the cyclic. So again, look for group A compounds. Is there any group A compounds? No, tak ada. So bila tak ada, okay, so the parent will be alkane. Okay, so next. So you can see here, this one have how many C at this cyclo ni? This one have 6 C. 1, 2, 3, 4, 5, 6. Okay, so 6C compared to this one, 4C. Which one is higher? 6C. So usually 6 carbon here, this cyclohexane will become the parent. If, okay, outside this cyclohexane doesn't contain any compound from group A. Okay, if there is a group A, okay, compound group A yang highest priority, dia akan jadi parent dekat situ. Means that cyclohexane jadi substituent. But right now, both outside the both of this compound is alkane. Kan? Dua-dua ni alkane. So, you can see here 6 carbon. I will show to you. Okay, this one become the parent. Okay, so 6 carbon. Okay, this one when it becomes substituent. Okay, substituent purple. Okay, so this one substituent. This one also substituent. Okay, this one is nitro, NO2. 4C, patutnya butyl. But it attached at the second carbon. So it is, try to look, refer to your table 4.15. So it is not butyl, but it is sec-butyl. You remember sec-butyl ada dash dekat sini. Okay, sec-butyl. Okay, so right now, sec-butyl. Sec, does it include in alphabetical order? No, sec tak termasuk. Ingat, iso and cyclo only. So parent right now is, parent is cyclohexane. Cyclohexane. So sec-butyl, B. So B, we put here C1. We start count from here. C1, C2, C3. Because N, nitro. B and N, of course B first. Okay. So it will be, the name will be 1. Sec-butyl dash 3 nitro cyclohexane. Okay, cyclohexane. Okay, so this is when you try to name, okay, when you have the cyclo compound as your parent. Okay, parent structure, parent name or root name, suffix. Okay, sec-butyl. So next. Okay. Okay, this one. Okay, class. Okay, this one. This one, okay. Dia ada kaitan relate with step 1, point number 4. Okay, step 1, point number 4. Okay, apa step 1, point number 4 mention is that when there are two longest chains of equal length, use the chain with greater number of substituent. Okay, refer pada point tu. Okay, so first one, we count the carbon chain, the longest carbon chain. So you can see here, let's say 1, 2, 3, 4, 5, 6, 7. Okay, 7. Okay, next is, wait, bukan lagi yang panjang tu. Let's say, warna biru pula. 1, 2, 3, 4. 4 here, 5, 6, 7. See, you can see here, we have two longest chain. Two longest chains of equal length yang sama, which is 7 carbon. So which one do we take? Is it the red or the blue? Okay, by referring to this point, the point number 4, okay, use the chain with greater number of substituents. Means that substituent banyak. Bukan number substituent besar, but substituent banyak. Lots of substituent, actually. Okay, lots of substituent. Okay, let's say I take the red one first. Red. Okay, if I use the red one, which one will become the substituent? This one. 1, 2, 3, 4. Okay, I will put here some note. Red, we have 4 substituents. Right? Okay, if we take the blue, how many substituents? Okay. If we take the blue, how many substituents will be? 1, 2. If we take the blue, it only consists 2 substituents. See? Okay. So of course the red. Blue is not, but red is correct. Okay. So we focus on the red. So I will erase the blue one so that you don't get confused. Okay. Okay, I will erase the blue so that you don't get confused. Just that, so right now you already know the steps. If you have 2 equal length, you will choose the higher number of substituents. Okay, the red, okay, we circle the substituents. 1, 2, 3, 4. Okay, so methyl, methyl, methyl. So 3 methyl. If 3, we put tri, T-R-I, tri, trimethyl. CH2, CH2, CH3 is propyl, not isopropyl. Right now, it is linear structure of substituent. So it is propyl attached to the 4th carbon. So for the next step, sama kita tengok dulu. Let's say I start from right pula. 1, 2, 3, 4, 5, 6, 7. Okay. So kita tengoklah. Kita just tengok. If we start with the red color, kita akan dapat 3, 4, 5, 6. Quite big, right? So if we start with green. 2, 3, 4, 5. Kecil. Of course. Okay. Kita start with the green one. So it will be, okay, trimethyl. Tri does not include in alphabetical order, so we look for the alphabetical order M, methyl. Okay, trimethyl, trimethyl. So M and P, of course M first. So it become 2, 3, 5. Okay, when it's the same substituent, okay, we put comma. 2, 3, 5. And then dash. Trimethyl. Trimethyl. 4. Okay. To bezakan, untuk bezakan, to differ for another substituent, we put dash. Okay. 4 propyl. 7 is heptane. Heptane. Okay. 2, 3 trimethyl, 4 propyl heptane. Okay. So that is the step. Okay, how do we name the organic compound? It is very easy actually. Okay. So finish practice 4.9. So right now, as you can see in practice 4.9, we only show example for alkane, which doesn't have any functional group from group A, yang mana highest priority, that we change the root name. So right now we start entering practice 4.10. Okay, 4.10. Okay. 4.10. Okay. Cis and trans. Do we have to show the cis and trans, Madam Ruby?
Say again.
Do we have to show the cis and trans example or just proceed in the lecture?
Let's look at the next slide.
Do you include cis and trans?
I think for this, yeah. For number 8 is cis and trans. Yeah.
Okay, cis and trans naming for alkenes. Okay, only for alkenes. There are some special conditions, okay, which we need to name it as cis and trans. Okay, cis, what we call cis is that on the same side of the double bond, okay, of the double bond, the compound is cis. For example, I will give you here, okay, the most common is 2-butene. Okay, 2-butene. Try to draw 2-butene first. 2-butene. What is the compound of 2-butene? CH3. Meaning that 2-butene alkene. The second double bond attached at the the double bond attached to the second carbon. Okay, so means that CH. Okay, double bond CH, CH3. Okay, for cis, okay, on the same side of the double bond, the compound is cis. Okay, what is cis? Okay, let's say we solely focus on the double bond right now. Kita cuba fokus pada double bond second and third carbon here, right now, here. Okay, kita tengok sini. Okay, we try to expand or buka. Or bahasa Melayu nak nampak tak sopannya macam kangkangkan dia. Okay, bukakan dia. C, okay, C double bond C, okay, I label 1, 2, 3, 4. Bagi nampak lah. Okay, let's say ini second and third carbon. So, second and third carbon, kalau kita tengok, we have H and also CH3, right? So, maksudnya kat sini, H, CH3. This one also H, CH3. So this one is the first carbon, this one is the fourth carbon. So on the same side of the double bond, the compound is cis. Okay. Maksudnya kat sini kita tengok sini. We take a look at CH3. Is it the same here? Same, left and right. Okay. So it becomes cis. Cis to butene. It can be also H. We can also refer to H because H sama. Okay, sama kiri dengan kanan. Side of the double bond. Okay, dia tak kisah. Asalkan ada salah satu yang atas atau bawah ni sama sebelah-sebelah. Terus dia jadi cis. Okay. Next, trans. Kalau trans, of course, the opposite. On the opposite side of the double bond, it is trans. Okay, same as example of 2 butenes here. Okay, C double bond C. Okay, C2, C3. When we expand, okay, let's say sini H. This one CH3. But at C3 here, we put CH3 up here and H down here. So this one we can see here, okay, CH3 right now is the opposite, not on the same side, bukan lagi bawah dengan bawah, but bawah dengan atas. So it become trans to butene. Okay, trans to butene. Yeah, I'm drinking water. Okay, so hopefully you get it for cis and trans. It only happened for alkenes because alkenes have double bond. So it will rotate at the double bond. Okay, it will rotate at the double bond. So the first one that we are going to discuss in practice 4.10 is question number 3. Okay, so listen. We will not discuss all the question in the practice. Of course, dia akan ambil masa lah, tak sempat. Okay, so for others, you try other question, other example, you try to do it. But yang kita orang ambil ni, the one that you can actually refer lah. Okay, boleh refer. Macam jadikan sebagai contoh. Okay, so right now, question number 3. Okay, we get this structure, class. Okay, and take a look at this structure. You can see there is bracket here, right? Ada bracket. Okay, bracket. Inilah, kurungan-kurungan inilah yang sebenarnya dia substituent yang menjadikan student banyak salah kat sini. My advice is that please expand the structure. Expand dulu bracket tu. Instead you cuba buka. Okay, what I will do is that, okay, saya buka kan. Saya ambil C double bond C first. C double bond C. Okay, at the left C here, we have 2 CH3, right? So saya buka. 1 CH3. CH3. Expand, please expand. Okay, and then C, H, CH2, C, H, CH3, CH3. Okay, then we can name it. Barulah kita boleh bagi nama. Okay, so the first one, okay, first step, okay, we have double bond alkene here. So the parent name will be in. Right? So count the carbon, the longest chain of carbon. So let's say 1, 2, 3, 4, 5, 6. Okay, so sekarang ni bila kita dah ada double bond as its root name, we must make sure that the numbering, okay, the numbering of substituent, sorry, the naming of parent untuk double bond ni dia kecil. Maksudnya, if you start like the green color here, 1, 2, 3, 4, 5, 6. Means that the double bond, we will name it at the 4th carbon. So it is wrong. Kita akan prioritize yang kecil untuk yang functional group ni. Kalau dia jadi parent. Okay. So the green one is wrong. Sebab kalau tak, 4 ni jadi besar. Nama dia. 4 apa ni? 6. 4 hexene. Wrong. Kita nak kecil. So, circle the substituent. 1. H is not substituent, 2. So we have 2 methyl here. Okay, so that the name will be, okay, look at the blue color. So yang green ni potong, salah. Okay, look at the blue color. 1, 2, 3, 4, 5. 2, 5 dimethyl. Dimethyl. 2, 5 dimethyl. Okay. Look at the double bond. It is located at the second carbon class. Ni. After second carbon here, we have double bond. So we put 2. 2 here. How many carbon? C. Hexene. Or another name that we can write. Okay. Cara lain yang kita boleh tulis nama ni adalah, okay, or, okay, still 2, 5 dimethyl. hex dash 2 in. Means that 2 is referring to the double bond of the hexene. So boleh tulis untuk kedua-duanya. Cara penulisannya. Make sure there's no space dimethyl hexane ni. Okay, tak ada space. No jarak here, tak ada jarak. Rapatkan.
Okay, so for question number 3 here, there will be no Cis-Trans Isomerism. Because there are 2 requirements to produce Cis-Trans Isomerism. Number 1, it must have double bond. Number 2, each of the restricted carbon at the double bond must have 2 different groups attached to it. So for question number 3 here, on the left carbon, there is 2 methyl group. So there would be no cis-trans here.
Okay, focus on the second and third carbon right now. Okay, take a look at this slide class. Okay, focus on the second and third carbon. Okay, let's say C, double bond C. So on the second carbon, we have CH3 and then CH3. So what do you mean? Madam Ruby means that at the second conditions, okay, it cannot be 2 same functional group, 2 same groups. If you take a look at C, second carbon here, you have CH3 and also CH3 and also CH3. So it is the same group, means that it cannot be cis-trans. Okay, it cannot be cis-trans. It must be different. If up here is CH3, then down here must be H or OH alcohol or CH2, CH3. Okay, must be different. Okay, cannot be the same. Okay, thank you, Madam Ruby. Okay, so proceed. Okay, proceed with the next question.
Before that, Sir Afif.
Yes.
Can we go back to question number 2 of practice 4.9? The slides. This is number 4 and then number 2, this one.
Yes.
Unfortunately, I can see the alphabetical order is not in place because
my mistake. Sorry.
I is included. Yes, included. So I would be in front of methyl.
Okay, I'm sorry guys, my mistake here. Okay, so I will erase this one.
Let's have a different name here where we can put isopropyl in front and then methyl at the back. It's okay, it's common, That's why we need to work together in team. Okay? And you guys have your study group and we now have to do it cross-check with each other.
Okay, okay. Thank you, Madam Ruby. Okay, so 3, the name for second example, practice 4.9, 3-fluoro, 4-isopropyl. 4-isopropyl, okay, and then 2-methyl. 2-methyl heptane. Please, okay, take note of this correction. Okay, this one is correct. Just now, what I did is 3-fluoro, 2-methyl heptane. 2-methyl, 4-isopropyl heptane. Okay, it is wrong because iso is included in the alphabetical order, so it should be in front. Okay, So do take note. Okay, so we proceed with practice 4.10 back. Okay, question, I believe that question number 5, example number 5. Okay, so right now, the one before that we only see one double bond. So right now, 3 double bond in this compound. So how do we name it? Okay, so first one. Okay, we have 3 double bond here. 1, 2, 3. Still the same. Kita guna rules yang sama. If 3 is tri, 2 is di. So 3 double bond. If 1 double bond is in. Kalau 2 double bond, tri in. Di in. Okay, di in. If 3, it will be tri in. So, start count. Okay, see here. Kita start pada kiri lah. Okay, from left, 1, 2, 3. So that numbering for alkene, it will be smaller. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, 7. So, 7 is heptene. But right now, we have, okay, we have 3 double bond. Okay, which is located at the first, third, and 5th carbon. Okay, so hepta dash 1, 3, 5 dash tri in. Is it correct, Madam Ruby? Hepta di tri in, right? Tipah?
I forgot to switch on the mic.
Yes.
It's correct.
Hepta.
Correct,
1,
but sometimes
3, 5.
other book also lose the A.
Lose the A. Do we have A or not?
Some books lose the A. Some books
yes.
also use A. So both are correct. Hept
Okay.
135 or
What do you mean?
hepta 135.
Okay, what do you mean by Madam Ruby is that some books we will also write like this. Hept 1, 3, 5 tri in.
Oh, actually, there is another one. Okay, 1, 3, 5 hep tri in. Hepta tri in.
Yes.
And then another one is, okay, another
1,
one
3,
is
5.
1, 3, 5 dash
Hepta tri in.
hepta tri in.
No space between hepta and tri in.
No space. So up to you. Okay, whether you want to use this one, or this one. Okay, so 1, 3, 5 hepta tri in, hept 1, 3, 5 tri in, or hepta 1, 3, 5 tri in. Okay, so next example is number 8 in your books. Okay, so you can see here, when you see this structure, this kind of structure that kind of open like this, like ketam, you know, okay, like crab. Okay, this is what we call cis-trans structure or geometrical isomerism. Okay, so as I've explained before, class, Cl and H. Okay, look at this C. Does it have the same compound up and down here, above and below here? No, Cl and H. Okay, so it can be cis-trans. Okay, sama juga ini. Tengok kiri dengan kanan, left and right. So Cl, Cl. is the same. Okay, so 1, 2. Double bond, alkene, ethene. So Cl attached to the first carbon and the second carbon. So cis 1, 2 dichloroethene. Dichloroethene. Because of the same side. This one right now, you can see here, Cl at the opposite. So it will be trans. Trans 1, 2 dichloroethene. Okay, 1, 2 dichloroethene. Okay. Doesn't mean the same side here I only refer to Cl. It can only also be H. When you have H here as the same side of the double bond, so it can also be as cis, okay, structure. Okay. So so finish for 4.10 for alkene. Okay. So next is from group A. So right now we are entering example that have functional group from group A. That will be the parent or the will change the root name of the compound. Okay. So in naming molecules containing one or more of the functional groups in group A, the group of highest priority is indicated as suffix. Yang mana highest priority, it become the parent, the suffix. Others are indicated by prefix with priority equivalent to any other substituent. Okay. Okay, for step 1, find the highest priority of functional group, determine and name the longest continuous carbon chain that include this group. Means that we have to start count the carbon from the highest priority of group A. Okay, so in practice 4.11, okay class, practice 4.11. Okay, this is actually question B, 1B. Okay class. So take a look. NH2. Okay, NH2 is in group A, which is amine. Group A. So the parent right now will become amine. Okay, so amine here is connected, is bonded to this cyclo what ni? 6 carbon. Cyclohexane. Means that this OCH3 here is the substituent. OCH3, you can refer to table group C, table 4.13, page 138. RO, alkoxy. So one methyl here. So methoxy. So actually the parent is now this one. The parent will be this one. So methoxy will become substituent. So the first one, NH2 amine, is we numbering as number 1 because it is the highest priority. So we start from amine here. 1, 2, 3. So 3-methoxy cyclo, okay, not cyclohexane, okay, but it will change to cyclohexanamine. because amine is the highest priority. So it will change the root name of the longest chain, the parent. It will become cyclohexanamide. No need to numbering the first one, the number one here. Okay, we already know when you want to do cyclohexanamide, okay, there are substituent. There is substituent at the third carbon, which is methoxy. Okay, next is this one. Okay, so example C, I believe that. Okay, example C. Okay, example C, 1C. So we take a look here. We have N here. So this one is amine. For amine, like a special case. Okay, we have here two alkyl group, CH2, CH3, and CH2, CH2, CH3. This one have 2 carbon, this one have 3 carbon. Of course, we will choose the longest. So the longest will be the parent. Okay, so 1, 2, 3, right? So 3 carbon here. So when 3 carbon is propan. So means that when this one is parent, become parent, means that this CH2, CH3, it become substituent. So substituent CH2, CH3 is what we call as ethyl. Just that for amine, for substituent, there's no numbering, but we'll put N. The name will be like this, class. Okay, it will become, we will mention M. And ethyl. Means that we know this ethyl attached to this N. And ethyl. So this one parent is propanamine. So propanamine. And ethyl propanamine. Okay. Is the example for D, Medirubi? Is the example for D, 1D? No. 1D. No.
D is tertiary amine.
Tertiary amine.
It's not there. I hide it.
Okay, okay. So for tertiary amine, okay, you can see there, okay, all the N, okay, already occupied with the alkyl group. So try to name it. Okay, try to name it. What will be? Okay, cubalah namakan dia. Okay, as I said before, I will not discuss all the question. Saya tak akan discuss semua question. But the question that we discuss is actually basic question for you to refer to other question. Okay, yang you boleh jadikan dia sebagai rujukan. Okay, so right now, okay, practice 4.11. Question, I believe that question B. Okay, B. So right now we have the highest priority, which is OH, alcohol. So it become all. So kita akan start count carbon. Okay, from here, from left, not from right, from left. Kalau you start from right, class. If you start from right, from right, let's say from right ni, 1, 2, 3, 4. The all here, alcohol become 3 all. 3, I mean 3 butanol, right? 3 butanol here. It's wrong. Right now kita nak highest priority ni, functional group A ni, dia numbering ni kecil. So we start from right. Okay, we start from right. So 1, 2, 3, 4.
You start from left.
Left. Left, sorry. We start from left, okay? From left, not from right. Okay, so alcohol at the second carbon and 4 carbon here, the longest chain, butan. But the tricky part here is that we have double bond here. We have double bond. So it is not butanol, but it will be butinol. Butinol. Not butanol, but butinol. So butinol, the double bond is located at the third carbon. So how to write it? Okay. So but 3 in. Okay, but 3 in. Is that 3 in the double bond is located at the third carbon. But 3 in and then 2 all. Is there any other name, Madam Tipah? Can you help me? Can it be 3, Madam Ruby? Can it be 3 butin 2 all? No.
No, I don't think so. It should be but 3 in 2 all.
So this is the only name lah that we can write. Okay. So this is the only name that we can write for this compound.
Or perhaps since this is an alcohol, maybe number 2 can be in front. That one we have to read more. It can be 2-butin 3-enol because the parent here is an alcohol. That can be a possible name also, but still we need to confirm and double check.
But for now, stick for this one. Okay.
Yes, that's right.
Plus, okay. But 3 in 2 all. Okay, thank you, Madam Ruby and Madam Tipah. Okay, remember these three refer to in hexene located at the third carbon. These 2 actually refer to alcohol which is located at the second carbon. But 3 in 2 all. Okay, next example is D. Okay, for D, class, there are two functional groups here that is in group A, right? We have alcohol and also amine. So refer back to group A. Which one is located higher? Okay, which one yang tinggi, highest priority? So if you look in your table, group A, of course, alcohol is above amine. So means that we will have to prioritize alcohol. So means that this OH, it will become the parent. Okay, it become the parent. Okay, so amine here become substituent. So when amine becomes substituent, we call it as amino. So 1, 2. Because parent, we start this OH, start from here, is 1. Count here as 1 and 2. So this cyclobutane, same like previous example, cyclohexane becomes cyclohexanamine. So this one, cyclobutane with alcohol, so cyclobutanol as the parent. So it become 2-amino cyclobutanol. Okay, 2-amino cyclobutanol. Okay, 2-amino cyclobutanol. Okay, that is for alcohol. Next.
Do we have a break, Afif?
Okay. Sure. Can we take a break?
I think you need a break.
Okay.
Yeah, me too.
So
Okay.
maybe we can share the link for the attendance for today's session.
Okay, Madam Rubah, share. I will stop share. You can share your screen, Madam Tipah. So we should continue. We take break about 10 minutes lah. 10 minutes Can? 10 or 5? 10 lah. Okay, 10 minutes Okay, 10 minutes. While we waiting for Madam Tipah share the links. Okay, you guys also can have a snack lah. Okay, makan-makan dulu sikit ke apa ke. Saya pun kering tekak juga ni.
Toilet break.
Break, okay?
Okay, can you see my slide? Yes.
No. Cannot see.
Not yet.
Let's see.
Kak Tipah ni, press the share button first. Alright.
Oh, wait.
Press the share button so that dia ada dekat sini. Desktop.
Okay. Can you see it? Can you see it now?
Okay.
Okay. So this is the attendance for today's workshop. Okay. So we have workshop keywords. Okay. So those who are not in this session maybe don't know this keyword, and please do not share this keyword with your friend who are not in this session. Okay. So you can go to this link http // okay, /pre-UCAM or workshop. Okay, or you can just scan the QR code, okay, that I've put in the slide. Okay, so let's take a break.
Okay, about attendance, Madam Tipah will update. Okay, wait. Students, try to access the attendance link again. Can you enter the link or not? Okay, and then update in Telegram. You can enter or not. Okay. Hello guys, I don't know, something funny You know what? Some of you
What happened?
scan the QR code using My Sejahtera. Oh my god! Aduh guys, ni bukannya My Sejahtera punya QR code ni. You know what? Just use your camera, guys. Just use your camera or type the link given.
Oh, Afif, iPhone je can use camera.
Yeah. You also can. Just download the QR code scanner. I think there's an app called QR code scanner.
It has to download something lah.
Tolonglah jangan buat lawak. Aduh, My Sejahtera pula. Ini apa? Check in. Check in apa? Okay, so we should continue. Okay, I believe that we will finish around, I think 12 lah. 12, so 12 or 12:30. Paling lewat pun 12:30. Okay, then we stop. Okay, so Bismillah. Okay, let's continue. So next. Okay. So ketones and ketones. Okay, the new one for you, ketone. Okay, so ketone will become parent. We will make it as on, O-N-E, ketone. Okay, so it becomes suffix. When it becomes suffix, it becomes ozo. Okay, so prefix ozo, suffix on. Okay, the first one. Okay, I will show you this one. The double bond O. Okay, B. This one B. Okay, B. So there are two functional groups in this compound, which is this one. This one is actually ketone. C double bond O. Ketone. And also this one as alcohol. So alcohol. So alcohol and ketone compare in group A, table group A though. Okay, which one is the highest priority? We will get ketone. So the alcohol becomes substituent. So become substituent, it become hydrox. The name will be hydroxy. Okay, so we start count the carbon from right. Okay, from the right. So 1, 2, 3, 4. 4 buta, right? Butanon right now. Ketone, butanon. Okay, so it will be 3 hydroxy. Okay, look at this double bond O located at the second carbon. So it become dash 2 butanon. Or 3 hydroxy butan 2 on. Is it butan or buta? Medarubi, betul pak? Butan, right? Butan 2 on, right? Butan 2 on. Okay, butan 2 on. Let's say like we separate this one. This one. Butan 2 on. Okay. So next example is C. Okay, for this example, okay, maybe some like okay. So identify the highest priority first. The functional group that is that exists in this compound. So right now we have here, this one is ketone. So this one is actually alkene. C double bond C ni. Okay, and this one is N. And this one is not H, but this one is actually CH3. Skeletal, remember? This one is actually CH3. So ketone will be the parent because of highest priority. So C double bond C here. Okay, C double bond C here. Okay, and this one NH3, this one H3 here will become substituent. But this one is like special case. After this, I will explain. But first, I will do the identify the longest chain. So 1, 2, 3, 4, 5. Right, 5. So as we know, N amino, N when becomes substituent is amino. In this amino class, in this amino, you can see that CH3 and this CH3 is the substituent for N. Substituent in substituent. In Malay, what Madam Ruby said is cucu, like cucu. Cucu. Cucu kepada ini, dia ni. So means that CH3 substituent kepada N, and this N is substituent to this parent chain. So how do we write this substituent in substituent? Okay, let me explain. So look carefully, class. So I will put here 4 first. Why 4? Because at this at N here is located at the 4th carbon in the parent. So 4 dash, I will put bracket. So why bracket? Because this one is substituent in substituent. Okay, 4 dash bracket. Okay, dimethyl. Dimethyl amino. See? Dimethyl amino. There's 2 methyl in this amino, which is located at the 4th carbon of the parent. So next, close bracket. Habis. Okay. Pent. Pent. Okay. Why pent? Because 5 carbon here. Okay. Pent 4 double bond located at the 4th carbon. Okay. Pent 4 in. Pent 4 in. For pentene. Okay. Pent 4 in. 2 on. Pentanon. Pentenon. Right? Pentenon. The 4 here is actually refer to the hexene. And 2 here is refer to the ketone. Okay. Pent is actually refer to what? How many carbon? 5 carbon. Okay. Pen. Can it be 4 pentene 2 on Madam Ruby or Madam Tipah? Can it be 4? Oh, I'm sorry. This one doesn't have any dash. This one doesn't have any dash. Kena dekatkan. Okay, I'm sorry. This one doesn't have any dash. My mistake.
One more thing, Sir Afif.
Yes.
We need to tell where the methyl is in amino group there.
And dimethyl.
Yeah. So before the word dimethyl, let's put N, N dash dimethyl.
Okay. So you can see here, class. Okay. 4 because of the located at the 4th carbon in the parent, and then N because dimethyl located at the N as a substituent. So N and dimethyl amino. Okay. Pent 4 in one. Okay, 4 dash and dimethyl amino pen 4 into one.
Excellent.
Okay. So next example. Oh, there's some note here. Okay, an aldehyde can only be on carbon number 1. So the 1 is generally omitted from the name. Is that we doesn't write the 1. Okay, the number 1 in the name. Special case, when the chain cannot include the carbon of the CHO, the suffix of carbaldehyde is used. Okay, carbaldehyde is used. So for example, this one, cyclohexane carbaldehyde. Okay, when the chain cannot include the carbon of CHO, means that this chain cyclohexane we cannot include, okay, the carbon of CHO here. So we use the carbaldehyde terms. So it becomes cyclohexane carbaldehyde. This is the special case for aldehyde. Okay. Okay, so next example is aldehyde. Okay, this one is example CH3, I believe example B. Right, B and also CH3, CH2, CH3 and B and C. Okay. So B first. This one is the parent. Look at the functional group, aldehyde. So it become al. So we start count the C from here. 1, 2, 3, 4, 5. So CH3 here we become substituent methyl. Okay, so methyl. So 5 propanal. Okay, so 2 methyl propanal. C.
Pentanal.
Propanal. Sorry.
Not propanal.
Pentanal. My mistake. Pentanal. Okay, thank you, Tipah. Okay, so this one C. 1, 2, 3, 4, 5. Okay, 5 same pentanal. Okay, CH2, CH3, CH3 substituent. Okay, located at the 4th and 2nd carbon, methyl and also ethyl. So the name will be, okay, 2 ethyl 4 methyl pentanal. Okay, pentanal. Okay, that is for aldehyde. So it should be easy. Okay, al. So next, practice 4.11. Okay, this one we are referring to the carboxylic acid as the parent, the suffix. So this one also has special case. When the chain numbering cannot include the carbon of COH, the suffix carboxylic acid is used. Okay, so you can see here, this is the parent right now, COH. So for 2-formyl, what is formyl? This one is that at this cyclohexane carboxylic acid here, this one is the parent here right now. Cyclohexane carboxylic acid is that this one is number 1, number 2, number 3, number 4. So 2-formyl, this one is formyl. Aldehyde become substituent. oxo ataupun formyl. Okay, it can also be oxo, but right now kita ada contoh lain lagi yang double bond O juga, which is ketone. So that we have to change the aldehyde to formyl. Okay, 2 formyl, 4 oxo. Cyclohexane carboxylic acid. Okay, cyclohexane carboxylic acid. Okay, sebab we cannot include, okay, the carbon COH into the chain. So we change the name into carboxylic acid. Okay, so next example. Okay, there are 3 examples here. Okay, practice 4.11, which is, I believe that this one is B. Okay, and then this one is E, and this one is C. Okay, take a look at B, E first, E first, E, because one carboxylic acid functional group. Okay, so COH, 1 here. So this is the first carbon. 1, 2, 3, 4, 5, 6. Hexane, Norway. But right now we have double bond. Hexanoic. Right? So substituent here, only one, which is methyl here, located at the 5th carbon. So number 5, number E will be, okay, 5 methyl. Okay, double bond located at the 3rd carbon. So 5 methyl, okay, 5 methyl hex 3 in Norway acid. Okay, hex 3 enoic acid. Can it be 5-methyl 3-hexanoic acid? Metal ruby, metal tipah. Can it be 5-methyl 3-hexanoic acid? Not sure.
I think can, because there's no confusion. Aoic or carboxyl will not be at carbon number 3. It will automatically be at number 1. So the 3 must be for the double bond.
Actually refer to the double bond, right? So this 3 is actually refer to this in.
Yes.
Okay, like this one, in. Because carboxylic acid, as you know, is the highest priority. So when it is highest priority, it will always be at the carbon number 1. Usually COH located at the end of the chain. And usually it is located at the end of the chain. So it will always be carbon number 1. Okay, for B. Okay, B, you can see here, we have 2 COOH class. 2 COOH right now. Sudah 2 COH. So, let's start mana? Start, let's say from the left. 1, 2, 3, 4, 5. If 1 COH, pentanoic. So, right now we have 2. So, it will be dioic. Dioic. Okay, not dipentanoic. Some mistake here. Okay, sometimes students do confuse. They buat dipentanoic acid, wrong. It is actually, okay, pentan because of 5 carbon, 1,5. 1,5 referring to the oic acid. So 1,5 dioic acid. Okay, dioic acid. Or Another name, we can write 1,5-pentan dioic acid.
Yes.
Okay. So that is for question B. Question C. Okay. So for question C right now, question C, COH is the parent right now. So we start count from here. 1, 2, 3. So we have 3 longest chain carbon here. So means that the one that will be substituent, NH2, and also benzene ring. See the one that I circle. Is it this circle included CH2? If CH2, it will be benzene. No, right now, okay, it will be phenyl as the substituent. Okay, so NH2 is amino. Okay, so the name will be amino and phenyl. AP, amino first. 2 amino, 3 phenyl. Okay, so 3 carbon, propanoic acid. Okay, propanoic acid. Okay, finish for carboxylic acid.
Okay, maybe we can discuss something about the structure of phenyl versus benzyl. Why we cannot name this as benzyl, Afif?
Okay, why we cannot, okay, name it as benzyl? Because look at the chain here. I counted this chain after phenyl. I counted it as the parent. It is included in the parent, so it cannot be benzyl. The one that can be benzyl is how? Okay, I will draw an example here. Saya akan tunjuk satu contoh. A very simple example. Okay, still kita guna COH. Okay, so CH2. Okay, katakan yang sama juga, amino. Okay, NH2. Okay, CH. Okay, CH. Okay, so sini CH2, CH3. Okay, this one is CH2. Or should I draw in the skeleton? Nak bagi nampak. Okay, I will draw in skeleton. Okay, skeleton. Okay, I will draw in skeleton. Okay, so double bond O, OH. Okay, so ini di bawah NH2. Okay, atas macam ni CH2, CH2, CH3. So this one pump. Okay. Something like this lah. Okay. CH2, CH3. Okay. This one. Okay, for example, like this structure. Plus, okay, I will erase this one. Nampak? Okay. So, look at this structure, class. This is the parent right now. So 1, 2, 3, 4, 5 carbon is the longest chain. So means that this chain here right now ni, yang ini, ni nampak ini CH2 right, ini C, H actually. So this one is the substituent. Okay. So means that this one, this structure will be, okay, the name will be amino and benzene. Amino first. Okay, it will be 2 amino. Okay, this one for this. 2-amino 3-benzyl pentanoic acid. But for this structure, okay, 2-amino 3-phenyl, okay, propanoic acid. Okay, is it good? Derby, Tipah?
Yes.
Okay.
Thank you, Sophie.
Very good.
Clear explanation, eh? So make sure you guys can differentiate between these two examples, benzene and phenyl. Okay. So next is derivative. Okay. The 6 common group derived from carboxylic acids are salts, okay, anhydrides, ester, acid halides, amides, and also nitrites. Okay, the one that is listed down here, the 6 common group is actually kita derive daripada carboxylic acid. Mana anak-anak dia lah. Okay, salts and esters are most important. Okay, salts of carboxylic acid. Okay, salts are named with cation first, followed by the anion. Okay, name of the carboxylic acid where ic acid is replaced by ate. For example, acetic acid become acetate. Butanoic acid become butanoate. And cyclohexane carboxylic acid becomes cyclohexane carboxylate. Okay. So ini kita akan tengok contoh especially in ester lah. Okay, in esters. Okay. Esters are named as organic salts. That is, the alkyl name comes first, okay, followed by the name of carboxylate anion. So common abbreviation ataupun dia punya functional group ni, you can see here, I try to expand C double bond O, O, R. R ni means that alkyl group. Okay. So how to name it? Okay, the one that is bonded to the C double bond O sebenarnya kita. This one. This one we call as alkanoate. Okay. The one that is bonded to the single bond O here, we call it as alkyl. Okay, alkyl group. Alkyl, alkanoate. Okay, for example, methyl ethanoate, propyl ethanoate. Okay, so next. Okay, we will see example of ester. Question, I believe that this one is question number 1. Practice 4.12. Okay, question number 1 and also question number 4. Okay, so take a look here. We know that this one is not carboxylic acid, but it is derivative for carboxylic acid, which is ester. So you can see here, 1 CH3. Okay, 1 CH3 here. CH3 here is actually located here. So this one is the OAT part, right? Alkanoate part. So this one, this name will be a bit harder. So look carefully. So OH, okay, we can see here this OH, okay, is the substituent for this compound, this chain. So this cyclopentane, you can see here 1, 2, 3. This is C. C is not included in the chain, right? Just now we learn, bila kita tak masukkan dalam chain, dia akan jadi carboxylate. Okay, so right now we will write the methyl first. This one, alkyl. So methyl here, okay, and then space 3-hydroxy cycloalkane. cyclopentane, panjang sikit carboxylate. Okay, 3-hydroxy cyclopentane, 3 OH becomes substituent located at the third carbon in the cyclopentane. Okay, and then carboxylate because it is out of the chain. Okay, doesn't include in the chain. So it become methyl space 3-hydroxy cyclopentane carboxylate of the ester. Okay, so that is for number 1. Okay, number 2. Okay, kita pisahkan. So this one alkyl, this one okay OAT. So this one cyclohexane, right? So become alkyl substituent. So cyclohexyl. So look at this OAT. Okay, OAT part 1, 2. So this number 2 is included in the chain of carbon. So it cannot be benzene right now. Bukan benzene ni, tapi this not benzene, but this benzene akan jadi a lone substituent, so it is become phenyl. So it become 2-phenyl because phenyl is located at the second carbon. 2-phenyl, how many C? 2. Ethanoate. Okay, ethanoate. Okay, cyclohexyl 2-phenyl ethanoate. Not cyclohexane, cyclohexyl because of substituent prefix. Okay, so finish for ester. Okay. Okay, I think this is the last part for this live session, which is aromatic compound. Okay, there's some note for aromatic ni. Dalam aromatic tu sendiri dia ada turutan dia, ada priority pula. You can refer to your books page right now, page 148. Okay, 147, 148. Okay. Nomenclature of aromatic compounds. Aromatic compounds are those derived from benzene and similar ring systems. Okay, as with aliphatic nomenclature described above, the process is determining the root name of the parent ring. Kita tengok parent ring sekarang ni. Okay, determining the priority name and position number of substituents and assembling the name in alphabetical order. Okay. Functional group priorities are the same in aliphatic and aromatic nomenclature. So sama sahaja, okay, dengan yang linear tadi tu, the one that we've learned before. So common parent ring, benzene, naphthalene, and anthracene, okay, but the one that we always use in this chapter is actually benzene lah. Okay, benzene. Okay, so so this one you can see here, okay. Mono substitute benzene. Mono means that one. Okay, means that right now we are looking for example that have only one substituent in the benzene. So most substituent keep their designation followed by the word benzene. So maksudnya dia dah follow dia punya designation substituent tu lah. Cl, chlorobenzene. NO2, nitrobenzene. So the third example you can see there is actually ethyl. Here is C, CH2, CH3, right? CH3, CH2 here. CH2. Ethyl, benzene. Okay. So this part here, actually you need to memorize lah. Okay. So because of what? Because this common substituent that we are learn right now, okay, is actually going to change the root name of the benzene. Dia akan mengubah nama benzene itu. Okay. So some common substituent change the root name of the ring. IUPAC accepts this as root names listed here in decreasing priority. So maksudnya akan ada priority dekat sini yang mana kita perlu utamakan. Okay. So the first one, the highest priority is when benzene is attached to the COOH. So the name will be benzoic acid. Okay, benzoic acid. That is the first one, the highest. The second is this one, SO3H, which is benzene sulfonic acid. Okay, and then next is aniline, NH2. Amine ni attached to the benzene, it become aniline. And then this one, CHO. CHO is what? Is actually aldehyde class. So dia akan jadi benzaldehyde, not benzyldehyde, but benzaldehyde. Please take note, benzaldehyde. Yalah, C double bond OH actually. Samalah, CHO pun also can. Ini nak bagi nampak lah. Okay, it is aldehyde. And then next is OH. Alcohol attached to the benzene, it become phenol. And then this one is actually methoxy. Okay, attached to the benzene, it become anisole. Parent name become anisole. And then the last one is methyl here. Attached to the benzene, it become toluene. Toluene. Okay, so do remember this priority. The highest is benzoic, benzene, okay, benzoic acid, COH. And the lowest one is methyl, which changed the root name to toluene. Okay, so let's take a look at the example. Ada lagi example? No, sebelum tu. Okay, disubstitute. So right now kita nak tengok kepada disubstitute. There are two substituents in the benzene. Okay, so let's say X and Y. So located, let's say we need number here is 1, put the number 1 and number 2 here. Okay, so 1, 2. Okay, we can also put the name, we become ortho or 1, 2. If IUPAC 1, 2, common name ortho. And also O also can, I believe that. Yes, Mary Ruby, Mary Tipah, O kan? Right? O. Okay, we can also put O.
Yes.
Meta. Meta actually referring to 1, 2, 3. Jadi 1, 3. 1, 3 here. Or it can also be like this, 1, 3 here also can. Same here, 1, 2 or 1, 2 like that. So meta. Meta means that we're referring to 1, 3 or M dash. Okay, and then the last one is para. 1, 4. 1, 2, 3, 4. Or 1, 2, 3, 4. Para. P. Okay, 1, 4. Okay, so let's take a look example here. Okay, practice 4.13. Okay, question. This one OH NH2. Question 2. And then this one is question 3. Okay, so right now we identify the highest priority first. You can take a look here. We have NH2 and also COOH bonded to the benzene. So between these two, of course, COOH become parent. So when COOH attached to the benzene, the root name is changed, not benzene anymore, but benzoic acid. So 1, 2, 3. So it become 3 amino benzoic acid. So can it be P amino? P amino. Let's take a look. If you want to write, as we know, 1, 3 is meta, right? P amino benzoic acid. Okay, can it be? So let's discuss here. as we know, P is 1, 3. So right now, we cannot put this name for this compound. Why? Because it's like 1 here is actually refer to the amino. Wrong. Salah. Actually, 1 must be start from the COH here, because COH is the highest priority. Okay, I will show you the one that we can use the name for orthometapara. Okay, but for this one,
it should be M.
sorry,
M.
Sorry.
Okay.
M.
1, 3.
Meta. M, 1, 3, meta. We cannot use M, meta. Okay, the one that we can use, we take a look at question number 1. Okay, I will draw this one up here. Okay, question number 1. Take a look at question number 1. Okay, we have here benzene. Okay, we have BR. They say sini, I change to CL. Let's say change to CL class. CL. Let's change to CL. Nak bagi nampak beza. Or maintain. Sorry. BR lah. Maintain. Okay, BR. Sorry. Okay, so take a look here. So 1, 2, 3, 4. So we can put here the name 1,4-dibromobenzene. So 1,4 here. Okay, 1,4 is para. We can put here because BR here, okay, will not change the benzene root name. Dia tak akan mengubah, okay, tak akan mengubah root name of the benzene. Okay, so dia tak akan mengubah, kita boleh guna para here. So para dibromobenzene, okay, benzene, or P dibromobenzene. Okay. Okay, P bromobenzene. So I believe that there's some discussion. Okay, maybe Madam Tipah. Madam Tipah, please. Maybe
Okay,
I do some mistake.
Just now for the first one, the first example that you discussed. Okay, so we have amino at carbon number 3, right? Yeah, and then COOH is at carbon number 1. So we know that the parent is benzoic acid. Okay, so amino there at carbon number 3, so the name can be 3-amino benzoic acid. Okay, if you want to use orthometapara naming, okay, so we can give name to this compound M-amino benzoic acid. Okay, so M-amino benzoic acid here means the amino is position is at carbon number 3. The COOH position is at carbon number 1, which will be the parent of this compound. Okay, so actually M-amino benzoic acid is acceptable. Okay, but yes, okay, but maybe a reminder to all of the students. Okay, orthometapara naming can only be used if we have only 2 substituents in the benzene ring. Okay, if you have more than 2 substituents, you cannot use orthometapara naming.
Okay, orthometapara 2 substituent only. Okay, take note, take note. Okay, thank you, Madam Tipah. Sorry for my mistake. Okay, so means that we can use M-amino. Okay, 1, 3. M, remember, 1, 3. Means that 1 is actually referring to the benzoic acid and amino at the 3rd carbon of the benzoic acid. Okay. the third example here. Okay. Almost 12:30. Okay, insyaAllah kita akan habis ni. Sabar sikit lagi. Okay, so right now, this one is OCH3. Ini methoxy. This one is actually COH. This one is aldehyde. So compare the priorities between methoxy, OCH3 and also aldehyde. The one is the highest is aldehyde. So the root name will be what? Benzaldehyde, right? So 1, 2. So the name will be 2-methoxy benzaldehyde. Okay, or okay, ortho. 1, 2, right? So ortho. Ortho-methoxy benzaldehyde or O-methoxy. Okay, benzaldehyde. Okay, you can use it. Okay, so next is, I believe that is the final. Oh, okay. Practice 4.14. Okay, the last example. One more. Okay, one more, guys. Okay, so right now, okay, take a look at here. We have benzene ring attached to N here. Not NH2, but NH. Means that this one have CH3 here. So this one is actually what? When NH attached, N attached to benzene, it become aniline as the parent root name. Okay. But then at CH3 here is attached to this N. So just like our previous example, it become N-methyl. Okay. N-methyl. Okay. So we start here, count the carbon here, 1, because this one is the highest priority. 1, 2, 3, 4. Or 1, 2, 3, 4, 5. Tak boleh jadi besar. Kalau you start daripada atas, it become 1, 2, 3, 4, 5. Besar 6 ring ya. So cannot. Okay, so what we will do, the name will be what? Okay, it will be 3, 4 first. 3, 4 dichloro. Okay, kita sebut yang substituent in the benzene ring first, and then N. Why N? Because methyl here attached to the N. N, methyl aniline. Okay. 3, 4 dichloro, okay, attached to the benzene, aniline. So N-methyl ni dia pada N lah, okay. So that is the name for this compound. Okay, 3, 4 dichloro N-methyl aniline. Okay, N-methyl aniline. So what happen kalau tak ada CH3 ni? Kalau tak ada CH3, dia hanya akan jadi 3,4 dichloroaniline. Okay, maknanya kat sini NH2 lah. Okay, 3,4 dichloroaniline. Okay, polysubstitute. Okay, the last one, okay, you may copy down the last answer, the last the last answer for example for practice 4.14, question number 2. So this one, take a look here. Why the name become 2,4,6 tribromotoluene? So you can see here, CH3 is the highest priority right now. So if we change the root name of benzene, become toluene. So we start count the number 1 here. 1, 2, 3, 4, 5, 6. So 2, 4, 6, tribromo because 3 bromo, toluene. Okay, 2, 4, 6, tribromo, toluene. Okay, Alhamdulillah, 12:30 for 2 hours live session. Supposedly 3 hours lah, tapi banyak kita skip. Okay, Alhamdulillah, hopefully you guys boleh faham lah, okay, what I delivered today. And turn to page 157 tutorial. You do notice tutorial for chapter 167, page 167. You do notice tutorial for chapter 2 have 2 parts, part 1 and part 2. So part 1 basically is for introduction of the organic, which you've learned about isomer, functional group and homologous, chiral carbon, stereoisomer, and etc. Okay, try to do it. Okay, and also part 2. Okay, part 2 is related to what we've learned today. Okay, since you are still fresh, kan, baru tengah fresh ni, baru tengah belajar, baru sudah belajar benda ni, cubalah buat part 2 punya tutorial ni. Try to do it, okay, and then refer to me, or Madam Tipah or Madam Ruby. Refer to your instructor. Check. Okay. I believe that from naming to drawing, it should be no problem. Bagi saya lah, apa yang saya experience sebelum ni, from naming to drawing tak ada masalah. Dia from drawing to naming, itu yang student selalu problem. From drawing to naming, because of what? Student tak reti nak identify which is the parent, the substituent to numbering. Itu common mistake student. Yes, I know. Memang kita buat kelas online, you guys tak payah lukis-lukis. Happynya, bahagianya. Tak payah lukis-lukis ni. But still, ingatlah ini ilmu. Kita belajar jugalah. Okay, mana tahu nanti, okay, masa depan nanti you akan guna untuk degree nanti dah boleh face to face. Kang terkapai-kapai nak lukis balik macam mana tak tahu. So please do it. Okay.
We really hope that you do this first before you ask for the answers from us.
Okay, please do it. Try to do it and then refer to us. Bukannya tanya ni macam mana nak buat, how to do it, sir, madam. Try to do it and ask, is it correct, madam or sir? Buat dahulu.
Yes, that's how you ask. Ini tu terus tanya, which formula to use, madam?
Okay, I believe that is all from me. Maybe Madam Tipah and Madam Ruby has something to say. Okay, maybe some reminder, peringatan ke mak-mak kepada anak-anak. Okay.
Okay, maybe I want to add something. Okay, just I want to stress when you give name, okay, to any organic compounds, okay, after if you have number after number, make sure you put comma in between the numbers. Okay, if after the number you have words, okay, make sure you put dash. Okay, and when Sir Afif shows the examples just now, okay, maybe some of you notice is some naming has space between them. For example, for the carboxylic acid, okay, for carboxylic acid example, so between let's say 15-11, 5-pentene dioic space acid. Okay, it must be like that. It must have the space. Okay, and another example for the esters, methyl, okay, methyl space, okay, and then 3-hydroxy cyclopentane in bracket, okay, and then carboxylate, no space between 3-hydroxy cyclopentane carboxylate. Okay, that's actually the basic rules for naming organic compounds. Yeah, so maybe Madam Ruby want to add something?
we're going to have a specific test only on naming, isn't it?
Yeah, of course. Yeah, it's actually chapter 4 IUPAC Nomenclature online test specifically for chapter 4.
Yes, we're going to have a special online test only for naming. So we are giving you this workshop as early as week 4 in order for you to take time. 1 day, 3 compound, 2 day, 6 compound, and so on. So I know today is a lot. I feel that you feel that today is something that is new, and there are so many things. The name of one compound alone is very long and very tricky. Yet there is a systematic way, and there is an easy step that you should follow in order to name them. So start with alkane first. Okay, one by one. At the beginning, start with alkane and then alkene. You have to do this on your own, and that's why we need to have a team of 3, a team of 4, so that your friend next to you should be able to point out, you should count from left, not from right. If you are alone, buntu. Okay, you cannot proceed because you don't have the idea how to proceed. So those are the things that is on your side. We have given you enough, the course book, the workshop, the videos, all of the channels. Inshallah, we hope we can guide you well, and now it's on your side. Thank you very much, students, for listening and attending. So with that, I give back to Sir Afif for Madam Tipah. Semua pas-pas bila nak habis.
Madam Tipah moderator, so she will end this live session. Maybe bagi pantun. Go on, Madam Tipah. Sending.
Alright, I'm sharing again the attendance link. Okay, for you to complete. And this is the attendance link. Okay, so thank you for listening to us patiently, and hopefully you understand what we have discussed today. Okay, and hopefully you can try all the practice questions, all the tutorial questions, especially for today's topic, which is naming organic chemistry. Okay, organic compounds, systematic and easy, a step-by-step guide. Okay, hopefully it is step-by-step that you can follow. Okay, and if you have any other problems later, you can always reach us through Telegram or WhatsApp. Okay, so that's all.
Okay, we will end this live.
Yes.
Okay, we will end this live. Okay, so hopefully you guys can start doing the tutorial, the naming. Okay, stay safe guys. Take care. Okay, jaga diri, jaga mental elok-elok. Okay. So hopefully you guys enjoy lah belajar organic chemistry ni. Itu yang kami harapkan. That is what we really hope, that you enjoy organic chemistry. Okay. So I believe that Madam Ruby, ada lagi? No.
Tak ada, nak bagi salam je.
Salam. Okay. So for Q&A, I believe that ada yang tanya. You can see the Q&A session. Madam Ruby dan Madam Tipah dah jawab. Thank you. Saya pun tak sempat nak tengok tadi, memang tengah cakap seorang-seorang. Okay. So for all question, saya rasa semua dah menjawab tu. Thank you Madam Ruby, Madam Tipah for answering the Q&A. Okay, itu sahajalah untuk hari ini. Okay, take care guys. We will end this live. Okay. Assalamualaikum warahmatullahi taala wabarakatuh.
Bye.
Okay.
Assalamualaikum.
Okay, don't worry. We will put this recording insyaAllah in YouTube.
YouTube,
okay?
yes. Thank you, Afif. Thank you, Madam Tipah.
Thank you, Afif. Yeah, thank you, Media Ruby.